Hello everyone, good morning, good afternoon and good evening. My name is Vishvadeep and I welcome you all on PW GATE Wallah channel, English channel, where we are going to discuss super 20 questions and that too of MSQ type. As I promised you guys that we are going to bring MSQ practice questions for you guys so that you can cover up that element which was missing in your preparation. Sir, we are not able to solve MSQ questions with proper accuracy. So today, only MSQ questions, 20 questions. And it's not only today, we are going to bring same series for all subjects which we are going to have here. Every alternate day, you are having one Maha revision, next day Maha practice, Maha Abhyas, and that practice is gonna be in two sessions, one MSQ, one a separate session of mixed all the type of questions. So I hope and I am very excited that you guys are excited and of course ready to learn. Audio video clear or not, just let me know. And quickly let me know if you guys are ready and excited for today's. I am not gonna waste much of your time. Just I will start the timer. Kahan milega? Where should I get the timer? Okay. Setting. No, I won't get timer here. I guess I'll get the timer. Where it is? Here it is. Okay, so this particular timer will work continuously for each question based on its merit. I will give you a particular time. Each particular question you'll have to finish in that particular time. Then we will discuss. Okay, audio video clear. Okay, great. So once you solve the question, you'll have to answer in the chat box itself. And one more thing for sure, you guys will have to answer your own thing. Until you get your answers, do not check the chat box so that you will not have any cheating or any influence of others' answer in your question. Let's go. And first question, here it is. Okay, question number 1, very simple. Cache memory it is from, and the timer starts now. I'll give you 2.5 minutes to think and answer it. Even 2.5 minutes is too much. Okay, let's think of it in that way. 2.5 minutes. Read and solve the question. I am sitting here next to you guys. Maha Abhyas session previous. This was the first Maha Abhyas session, beta. Today 7 p.m. next Maha Abhyas session will be there. This year, this is the first course we are going to start. MSQ तो मौत आती है बेटा जी, मौत हमें आनी नहीं है, दिलानी है. We will have to solve all type of questions to get the better rank in the examination. Okay, 2.5 minutes. Everybody be serious. Solve the questions. Okay, 2 answers, 2 are different. A, D, B, C. Think of it properly. B, C, D, B, C. Okay, different answers. Different. One and a half minute gone. I guess 2 minutes are okay, but still people are quick here. So I'll give you 2 minutes and then we will discuss the question quickly. If you guys are able to be here, you guys should like the session also. If you are here, like the session also. Very different answers. Okay. 2 minutes gone. Let me stop the timer. Reset it. Corner. Which of the following is or are true? True statement. We will have to find out true. Size of tag memory needed in cache control is larger for set associative cache as compared to fully associative cache. Yesterday only in Maha revision I have explained this, that tag is largest maximum in fully associative mapping and minimum in direct mapping. In between these two, you will be having value in set associative mapping. Now listen, fully associative mapping when have tag maximum, of course tag directory also. Why? Just because tag directory size formula is same to same. What is formula? Number of blocks in cache multiply by tag size plus extra bits. If tag size increases, number of tag directory size or tag directory size also increases. Number of blocks will remain same to same. Block size, cache size same to same. So this statement is wrong. Size of tag directory or tag memory needed in cache controller larger in set associative? No, fully associative has bigger. Size of tag memory needed in cache controller is smaller for direct mapped cache as compared to set associative? True. Yes, just because tag size is minimum. Hardware requirements are more in set associative cache as compared to direct mapped cache for hit miss checking? True. Yes, just because as soon as you increase the associativity, we need more multiplexers, we need more comparators. As soon as more and more associativity increases, hardware requirement increases. That's why yesterday I told you that the fully associative cache has very expensive hardware setup, and that's why we don't use it. Fully associative cache can have less misses as compared to direct mapped cache? True. Yes, can. Statement is not always. Can have. Possible? Yes, possible. Anyway, yesterday I told you there is no dash 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 type of miss in fully associative. What type of miss is not there in fully associative? Conflict miss. And direct mapping, too many conflict misses. So those type of miss will be reduced. Fully associative cache can have less misses as compared to the direct mapped cache. So B, C, D are correct for this particular question. True statements are B, C and D. Where can we get? Yesterday's PDF you got, na? Yesterday's PDF after the class, immediately in 15 minutes I have dropped on the Telegram channel. Telegram channel नहीं पता है? अरे यार होना चाहिए. This is the ID @Vishvadeep sir. Vishvadeep sir PW is the name of the group. Just go and you can get the PDF of yesterday's class. As soon as today's class will be over, I'll drop this particular PDF also there. Okay. Next. Very simple question. 1 minute. Hardly 1 minute I'll give you for this one. Hardly 1 minute. ऐप पर अवेलेबल नहीं है बेटा. अरे on Telegram channel it's free na. You can make a free account and open it. Download the PDF and then delete the app. Again you do the same thing whenever you need. One minute gone. Stop. Okay, so many answers I do have over here. Let's see. Cache mapping helps in. For what we use the cache mapping? Two reasons. Yesterday only I told. When we bring a new block from main memory to cache, where to place it, mapping helps me. Second, when we search in the cache memory, at that time also we need cache mapping. Placing a main memory block into cache, yes. Searching a main memory block into cache, yes. Calculating number of cache misses for a specific program execution. Do we need cache mapping for calculating number of cache misses for a specific program execution? No. When miss occurs, I don't need mapping. Directly, no. Placing a block from hard disk to cache. Do we bring a new block from hard disk to cache? No, we don't bring a block from hard disk to cache. Never. So option A and B are correct. That's it. We are not bringing any block from hard disk to cache. Blocks are always in main memory. We bring the blocks from main memory only into cache memory. So only A and B are correct for this question. Simple it is. Very simple. Next question. Question number 3. Ooh. This is given in hexadecimal, but this is given in decimal. Hexadecimal, decimal. Remaining all values decimal. Wow. Direct mapping question it is, okay? Look at this direct mapping. I think I'll have to give almost 4 minutes to solve this question. D was tricky. There was no any trick. It's a knowledge. You have the knowledge, you get the answer. You don't have knowledge, you don't get the answer. As simple as that. I am not talking too much so that you can solve the question. Okay, 2.5 minutes gone. I'll give you 1 more minute. Keep solving. Half minute more, 3.5 minutes are sufficient, I guess, to solve this question, just because in GATE examination also you will have on an average this much time given. Okay, so many answers are almost matching. Let us see how does it work. So what is the question? In direct mapping, which particular address maps to where? For that, we have address format. Just divide the address format. In the address format, we do have main memory address always divided into 3 parts. here is the tag, here is the cache memory block number where the given address will map, and here is the byte offset. So in the address, we need to find out cache memory block number. That's it. Nothing else. So let's first see how many bits will be needed. 32-bit address, 8-bit hexadecimal head, 8-digit hexadecimal, 32-bit address. Okay. So 32-bit address divided into 3 parts. What are the 3 parts? Block size 128 bytes, so 7 bits gone for byte offset. 512 blocks, 9 bits for cache memory block number, 9 and 7, 16 gone, so 16 bits for tag. Okay, now what I need is this particular address. From there I need cache memory block number, 9 bits, left 16 bits. 16 bits means hexadecimal 4 digit, 4 bits. Each hexadecimal can be represented in 4 bits of binary. So 4, 4, 4, 4, total 16 gone. Now I'll have to have A. A is 1010 of binary. Then 7, 0, 111, total 8 bits. And then 1. Only 1 bit of 1. 1 represented like this way, but I need only 1 bit. Total 9 bits gone. This is the cache memory block number where this address maps to. Now this particular binary is 334 or not, that is what I'll have to verify. That's it. So 1, 2, 4, 8, 16, 32, 64, 128 and 256. So 256 plus 1, 2, 4, 8, 16, 32 and 64 plus 64 plus this is 14. 334. Exactly 334 it is of decimal. True it is. Option A is correct. Option A is correct. Let's see option B. Option B, 4-bit, 4-digit hexadecimal gone for tag 50F. 50 and from F only 1 bit. This is the binary. Let's convert it into decimal. 1, 2, 3, 1, 2, 4, 8, 16, 32, 64 and 128. 128 plus 32 plus 1, which is 161 of decimal. 161 of decimal. Yes, option B is also correct. Option C, 4-digit gone for tag 16-bit. Now convert this to 0010, then F 1111, then 7, first 0, remaining 1 I left. Okay, what it is? 1, 2, 4, 8, 16, 32 and 64. 64 plus 30, 90, not 32. This is what? 15 into 64 plus 30, which is 94. Option C is wrong. Option C, not 96, it is 94. Option C is wrong. Option C is not matching. And then option D, 4-digit hexadecimal gone for tag. Now 0A, 0, then A is 10, then 0. No, B is starting from 1. What it is? 1, 2, 4, 8, 16, 16 plus 5. 16 plus 5, 21. Nice. 21 of decimal. 21 of decimal. It is true. Option A, B and D are correct. See, hardly 5 minutes. If you know the method, hardly 5 minutes. And this method, how do you know? By practice. Simple. MSQ questions are not difficult. It is simple. You will have to take every question or every option as one question. And every question you will have to solve correctly. A, B, D are correct. Perfectly fine. So many students have given correct answer. So many have just given random answers. No, random answers will not work, my dear friends. Next question. Okay. Another question of mapping itself. Initially, I have brought all the questions of cache memory so that you guys can have better understanding of cache memory. Then we will have next important chapters, pipeline and remaining things. Concept is really good. It's taking more than 3 minutes to solve every question. You will not get every question. You will not take more than 3 minutes beta. You will have to have practice. Similar and seen questions you can easily solve in lesser time. Maha revision video is on main channel. GATE Wallah EEECCS on that channel. It is in Hindi. This class will be helpful for conceptual learning. Yes, not exactly the same question will come in the BAC, just because BAC is not the exam where MSU type questions are coming. Is it good if I attempt one mock daily? Full length mock? No. It will take a lot of time, plus your concentration will not be good. Only C. Lots of students are writing A, B, C. Every day, if you will write the mock, your concentration will not be good. Oops. Chalo. Okay, let's solve this question. It will not take much time, I guess. Now, next thing is what? See, the question is cache memory has 2 power 13 blocks. Each block 32 bytes. CPU generates address of 32 bits. Cache controller stores one valid bit, one modified bit, and tag bits for each data. Metadata entry means for each particular block, you will have to maintain tag and additional 2 bits. The cache controller has maximum memory of 19 kilobyte. Maximum memory. Okay. The cache organized as k-way set associative. Possible value of k is what? Okay. So first of all, what you will do is, I don't know what is the size of tag. Until I know the size of tag, I cannot calculate what is the value of k. Why? Just because in main memory, let's say address 32 bits, tag, set, and byte. Byte offset block size is 32 bytes. So byte offset 5 bits gone. Tag I don't know. If tag I don't know, set offset I'll not be able to know. Why? Number of blocks are 2 power 13. If it is direct mapping, then 13 bits will be used here. But if it is two-way set associative mapping, then bits will be what? Lesser than this. Tag will increase. Tag will increase eventually. So what happens in that case? What happens in that case is, I don't know what is the mapping. Based on mapping only, I'll get to know how many bits are there in the tag and set offset. Now, tag I can calculate from tag directory size. Yes, tag directory size maximum given is 19 kilobyte. Yesterday I told you it will be given in byte. Convert that into bits. 19 kilo into 8 bits is equal to what? number of blocks in cache multiply by tag plus extra bits. Extra bits, how many? One valid, one modified. Bits and bits. See, now the thing is, whatever tag directory size you calculate for any type of mapping you have, this should be lesser than or equal to this particular memory. Just because you have maximum 19 kilobyte memory, if your tag directory size is equal to this, fine. If tag directory size is even lesser than this, that is also fine. So I will change a small thing over here, and that is this. My tag directory size should be lesser than or equal to available memory I do have. This is the maximum possible memory. My tag directory can store exactly in this amount or even lesser than this. If my tag directory is lesser than this, still I can store, no issues at all. Now let's solve it. Kilo and 8 gone with this. 19 is greater than equal to tag plus 2. Tag should be lesser than or equal to 17 bits. So any particular mapping which is giving me tag 17 or lesser will work here. So if I take tag as 17 bits, how many bits are remaining for set offset? 17 and 5, 10 are, 22 are gone. Remaining bits are 10 here in set offset. From 13 to 10, number of sets, if you calculate, okay, I can give the method also. Number of sets in cache memory is equal to number of blocks divided by associativity. Number of sets are 2 power 10 with 10 bits. 2 power 13 divided by k. K value is 2 power 3, 8. So any value where tag is 17 or even lesser, how is it possible to have lesser bits in tag? When index is more, tag is lesser. So any associativity which will have tag 17 or lesser, which means 8, 4 and 2, all three options are correct. All three options are correct. Possible value of k. So all three options are correct. Maximum possible value of k is 8. But even if you have 4-way set associative, set offset will have 11 bits. If 11 bits, then 16 bits tag here. If you use 2-way set associative, set offset will have 12 bits and 15 bits will be here in tag, which is still lesser than 17, and still we have maximum possible memory to store our smaller tag directory size. So option A, B, C are correct. Everybody got it? See, these are small things which you know also. The concept you know, but how to apply it, where to apply it, if you don't know it, you make mistakes, and such kind of mistakes are taking lot of your marks. Agree karte ho? Do you agree with that point? Yes. Ha sir, we know the concept. So every concept we know that if associativity increases, tag size also increases. Set decreases, tag increases. Fully associative, too much tag. We know that. But to apply that concept here is the most important part. That is why practice is most important thing in the last months. Chalo, start now this question. Okay, stop and start now. I will give you only 1.5 minutes to solve this question. Sir, can we use hit and try here? Where? Yes, you can, but it will take a lot of time. Wastage of time. I am also left hand writer like you. Become IIScN also like me, and I will be happiest person in this world. Yesterday only we have discussed it. Yes. Okay. Stop. 1.5 minutes is too much. System has L1 cache, L2 cache, and main memory. Which of the following is correct? Inclusion policy, the L2 cache is filled with the blocks replaced from L1. No. No. In inclusion policy, in L2 we bring the block from main memory, not from L1. For sure. Replaced block of L1 are not going into L2. They are always into L2. No issues at all. Exclusion policy, L2 cache is filled with the blocks replaced from L1. Yes, true. L2 cache is victim cache. All the victim blocks which are replaced from L1, those blocks are going into L2. True. Inclusion policy, the L2 cache is filled with the blocks copied from main memory. True. In exclusion policy, L2 cache is filled with the blocks copied from main memory. No. They are not coming directly from main memory. The blocks in L2 coming from L1 which are replaced from L1. So option B and C are correct. When we will be having GATE GBGs for GATE 2026, already full length tests are there in the test series. Na? Next question. Full length GBGs are already there na? In test series. One and a half minute max again. Not more than that. Marks are very less in mocks. Practice more. Analyze where you are making mistakes. When to use pipeline diagram and when to use short tricks. I have given only short tricks, not the diagrams ever. All the questions we have solved only through the short tricks. Different various types of questions, various types of short tricks. I have not explained any question without any short trick or direct trick. If you have learned along with me, you will only have short tricks. Okay, gone timer. Consider a cache 512 kilobyte, block size 16 byte, main memory address 32 bits. Which of the following possible tag size for any type of mapping? Any type of mapping. Okay, minimum tag where you have. Minimum tag where you have. Minimum tag. In direct mapping. So let's go with the direct mapping first. According to direct mapping, let's make the address format. Tag, block, and byte offset. Yep. Yes, byte offset. 4 bits gone. We know that these 2 bits log off cache memory size. Cache memory size is 512k. 512k, which is 19 bits. These two are 19 bits. Main memory address 32 bits. 32 minus 19 is 13 bits ka tag. 13 bit tag. 13 bit tag. Yes. So minimum tag possible for this particular question is 13. Lesser than 13 not possible. Why? Lesser than 13 why not possible? Just because in any possible mapping, direct mapping gives the minimum possible tag. If minimum possible tag direct mapping gives, it is 13. Lesser than 13, no any other mapping can give you. More than 13 possible? Yes, possible. But how much? How much? Sir, maximum tag is obtained in fully associative mapping. Fully associative mapping gives tag how much? That also you will have to verify, na? Without thinking, you just give me all the values more than 13, then it can be wrong. That is where you are gonna go with mistakes. Byte offset 4 bits. Among 32 4 bits gone, then tag is 28 bits. That's it. Maximum possible tag 28, minimum possible 13. All values between these two will be possible. So I will write possible values of tag between 13 and 28. What options? B and C. That's it. D is not correct. So many students were thinking, sir, D is also possible. No, re baba. D is not possible. Okay, next question. It is talking about hit and miss. 2.5 minute maximum for this question. Told you, right? I have promised you guys I will bring good quality questions. I will bring good quality questions. Great, beta. Possibly the same question been asked in GATE 2026. Similar question, I don't know, but conceptually, these only things will be. IIC 26. You need to assess if you think it happens like that way. Okay, 2 minutes gone. I don't think so. It should take that much of time. What question says direct mapped cache with 16 blocks, numbering 0 to 15, memory with 128 blocks, cache currently contains 0 to 15. What does it say? In the cache memory, at block number 0, main memory block number 0 is already present. At 1, block number 1 should be present. That is what main memory mapping or main memory block mapping in the cache memory happens. 15 will be present at 15. So these blocks are present. What is the block size? 128 byte. What is the block present? 128 byte. Okay, so which of the following main memory addresses decimal value will be present in the cache memory? Look at this. You are saying, sir, block number 0 of main memory already present in cache. Block number 15 also present in cache. 0 to 15, all these are present. You need to just calculate the address. Block number 0, what will be the address? 0 to 127. How? 128 byte block. Then next 128 byte, block number 1. Next 128 byte, block number 2, and so on. Block number 16 will start from where? Block number 16 will start from 16 into 128 address. Block number 16 will start from 2048. Address 2048. So, any address which is lesser than 2048 present in cache memory. Any address which is lesser than 2048. So all these are addresses 0 to 2047 addresses present in cache already, just because blocks 0 to 15 are present. Any value 2048, not this, not this, not this, only option B is correct. Only option B is correct. Only option B is correct. Next question. Pipelining. Simple question it is. We have already solved 7 questions. Sir, not able to solve using short trick beta either if the question has a level which is not beyond, which is not in the gate level, or something else you are missing. Just ask in the groups, Telegram groups, people will reply. सर ऐसे हम नहीं सोच पाते बेटा जी. You will have to practice. If you will practice more, you will be able to think of it. More and more practice, and you will be able to solve the questions quickly. This is very easy question. Very easy question. You don't have to wait for even lot of time to answer this one. I think this much time is enough for you guys to think of this. Okay, variety of answers. See, this is what the beauty of NAT and MSQs. Variety of answers are coming. Which of the following is or are not false? Ha ha ha. Not false means true. Regarding pipeline. For single input, non-pipeline is better than the pipeline. True. Pipeline is certainly not helpful for single input, just because we go for maximum segment delay and for TP selection or cycle time selection, and apart from that we have the buffer also. Because of that, single operation time is too much in the pipeline as compared to non-pipeline system. But as soon as you increase the number of inputs, the scenario changes. Pipeline becomes immediately better. Pipeline can be fruitful when multiple different processing is applied over multiple inputs. No. Pipelining is helpful when same processing is applied over multiple inputs. Same processing over multiple inputs. Option B is correct. No. Wrong. Multiple different processing. No. Same processing over multiple inputs. Pipeline with single segment cannot provide parallel processing. Of course, true. To make parallel work, each segment should do work in parallel. So if we have single segment, it is kind of non-pipeline system only, na? There is no any parallel work at all. D. Non-pipeline system does not require intermediate buffer or register. Yes, true. Option A, C, D are correct here. So many of you have given correct answers. And of course, it is true and easy also. Very easy question it is. Next question. Simple, very simple again. Very simple. 1 minute to solve this question. Okay, stop. Six segment pipeline, in which segment delays are these. Pipeline uses intermediate buffer also after every segment with delay of 2 nanosecond. Which of the following can be possible speed up ratio of pipeline as compared to corresponding non-pipeline system? See, I will talk about ideal condition. In ideal condition, we have the maximum speed up, maximum possible speed up. So let's calculate maximum speed up. Maximum speed up we calculate in ideal condition Tn divided by Tp. Yeah? Yes or no? Yes. Let's try to have the same thing for given calculation. Tn is summation of all the segments. Sum of segments, which is 32 plus 34 plus 20 plus 26 plus 38 plus 27. How much it is? How much we are getting? 32 plus 34 plus 20 plus 26 plus 38 plus 27. 177. एक बारी check कर लेना. Just please check once. 177 nanosecond. TP will be maximum of all these. 32, 34, 20, 26, 38, 27 plus register delay, which is 2. 40 nanosecond. So 177 divided by 40 is the maximum possible speed up. 177 divided by 40 is 4.425. Any value which is lesser than this is possible. C and D are correct. Why, sir? See, this is the maximum possible speed up in ideal condition. When we have problem of hazard, then speed up decreases. Why? We increase the CPI more than 1. So if CPI is increased here, speed up will be decreased. If speed up is decreased, speed up can be achieved lesser than this. Yes. So actual speed up can be lesser than this possible. So 4 and 3 possibly achieved speed up we can have. Option C and D are correct here. Simple question. Maximum speed up, everything will be lesser than that maximum. Next question. This is again very easy question. Hardly 1 minute you will take to think of it. This is so simple, little tricky, but very easy question. Variety of answers I am getting. I'm still waiting. Like the session if you are enjoying. Okay. Look at this. Question is very simple. Question is very simple. Look at this. 5 segments are there. A segment which takes maximum delay among all segment is divided into 2 segments of equal delay. If suppose the segment had initial delay of 10 nanosecond. So let's say one segment among 5, let's say segment 1, 2, 3, 4 and 5. Among 5 segments, maximum segment delay was 10 nanosecond. That segment later on divided into 2 parts of equal delay 5 nanosecond, and these definitely were having some delays lesser than 10, some delay lesser than 10. Why lesser than or equal to? Why? Just because maximum segment delay was 10, which we have divided into 5 and 5. Now what is the question is, after dividing the segment of maximum segment delay into two parts, what is the new cycle time of the pipeline? There is no any cycle time overhead, which means no any register delay or etc. Now, maximum segment delay can be of these. If these are 10 or lesser than 10, fine. But if all of them are lesser than 5, then 5 will become the maximum segment delay. So new pipeline can have TP between 5 to 10. New segment delay maximum can be 10 if other segment also will have maximum segment delay 10 exactly. If not, then lesser than 10 but not less than 5. Why? Just because we have a segment of delay 5, less than 5 maximum segment cannot take. So option D is correct here, only D. Just because question says not be a pipeline cycle time. Not. क्वेश्चन ही समझ नहीं आ रहा बेटा, प्रैक्टिस करने पे आएगा. As much as practice you will do, you will be able to get the answers. So possible answers are 5, 6 and 7, but not a possible pipeline cycle time. Not देखा भी नहीं. You haven't even seen this not, na? It is in front of your eyes only, but your eyes are not trying to see it. Why? It is very easy question. Very, very easy. Chalo, next question. It may take time. Wow. Big question it is. I will give you 5 minutes. As many as questions you will practice, you will have better understanding how to solve the questions, how to read the question, how to attempt the question. So it's very simple. Keep practicing and practicing and practicing. It's very rare that you will be having only one answer correct in MSQ, so don't worry about it. Okay. Variety of answers. A few more seconds. Okay. Stop. Six segment pipeline in which all segments take one cycle for each instruction except the exception execution phase. Execution phase take three cycles for multiply instruction, six cycle for division instruction, one cycle for addition, one cycle for subtraction. So each multiplication instruction will take 3 minus 1 2 stalls for each multiplication instruction, and each division instruction will take 6 minus 1 5 stalls. Fine. Suppose a code segment is executed on this pipeline in which total 8 instructions are executed and total 27 cycles needed for execution. Okay, which of the following is or are correct regarding number of instructions of each type? Option A says addition 2 instruction, subtraction 2, multiplication 2, division 2. Option B says addition 1, subtraction 1, multiplication 3, division 3, and so on. So how do you check it? We know that the method is simple. Option A, if you check, first of all, without hazard, number of cycles are k plus n minus 1 plus total stalls. K, number of segments 6, number of instructions 8 minus 1 plus stalls. Multiplication instruction 2 stalls, division 5, multiplication 2, division 2 instructions. So 2 times 2 plus 2 times 5. How many cycles? Option A 13, 13 and 10 23 plus 4 27. Option A is correct. Option A is correct. 27 cycles are needed. See, ultimately, these many cycles are anyway needed. 6 plus 8 minus 1. How many additional cycles? Multiplication 3 and division 3, of course, will not be possible. Multiplication will take 2 stalls each, and division will take 5 stalls each. This will go beyond 27 for sure. 13 plus 6 plus 15. How much? 10 10 20 6 5 11 12 13 14 34. 34 cycles. No, 27 cycles. Option B wrong. Option C. A. These many cycles needed. Additionally, 3 and 2 of course will not be possible. Beyond. 3 into 2 6 plus 10 13. 13 and 6 19 29 cycles. 29 cycles? No. Option C is also gone. Option D 2 and 3 of course will be beyond. 6 plus 8 minus 1 13 plus 2 into 2 plus 3 into 5. 3 into 5, 15 and 13, 28 plus 4, 32. More than 27 cycles, option D is also gone. Only option A is correct. Only option A is correct. Correct option, only A. But in this case, operand fetch should be used. Operand fetch for what? Operand fetch for what? Shubham Kumar Shukla, your calculations are wrong. That is not the way you do that. Chalo, next question. Very simple. Not the timer even needed. Simple, simple, simple. Okay, what is the answer? Which of the statement is or true? A general pipeline cannot detect the data dependency. Yes. A regular pipeline cannot detect the data dependency. That's why the hardware solutions are provided in which hardware can detect the data dependency and then can provide the solution like hardware interlock or operand forwarding. But if it does not do that, then we need the solution from compiler called as delayed load. Second statement is also correct. Delayed load is the solution provided by compiler. When compiler sees that my processor, pipeline processor is Dumbo, the processor CPU will not be able to detect the data dependency, then compiler itself provides a solution through delayed load. Operand forwarding can solve all the dependencies. No, we have seen operand forwarding cannot solve all the dependencies. Memory dependencies are unsolvable. The data dependency always creates stall. No, only a few times data dependencies may create the stalls. Like wow and war type of dependencies will not cause the stall. So only option A and B are correct. These are the classroom training statements only. Out of order execution is same as delayed load. Yes. But every time out of order solutions are not possible. That's why we can have either no operation instructions or out of order some independent instructions pushed or moved after the dependent instructions or between the dependent instructions. Yep. Next question, again very simple. It is from IO device. Very, very simple question it is. At the end, after the session ends, I can talk for a few minutes to you guys so that you can have certain of your questions solved. Okay, what the question says. Which of the following is or are not false? Again, not false means true. DMA controller is a special purpose processor. True. Why? Just because it can generate the address and control signals for accessing the memory and IO device. True it is. CPU can perform some operation during the DMA transfer. Yes. What such operations? Which do not require buses. Which do not require buses. Internal operations CPU can do. CPU can enable DMA hold acknowledgement after instruction fetch cycle. Yes, true. CPU can provide the control of the buses. Ultimately, this statement says that CPU can give the control of the buses to DMA controller anytime between current instruction execution. True. Possible it is. CPU can give the control of the buses to DMA controller anytime in between the instruction execution. CPU will not have to wait for current instruction completion. That is true for interrupt service. For interrupt service, CPU will have to complete the current instruction. But for DMA service, CPU doesn't do anything. CPU sits aside and DMA is doing the work. So CPU can give the buses anytime between the instruction execution also. DMA transfer stops when starting address becomes 0. Nahi. DMA transfer stops when data count becomes 0, not starting address. So option A, B and C are correct. D is wrong. Data count becomes 0, stops the data transfer. Okay? Perfect. Yes, count register. Next question. Very simple question. You read and tick mark. You don't have to think much about it. Tripti ji, C option in the previous question says that CPU can give the control of the buses to DMA controller anytime. Anytime means even if current instruction CPU is executing, instruction fetch is done, decode is going on, during that time CPU can give the control of the buses to DMA controller. Yes, true. That is what the statement. Next question. A very easy question. Control unit generates control words so that it can make the other components work. Register to register data transfer, condition check for branch, memory read, memory write, IO read, IO write, ALU operation. Everything works based on the control unit's control signals. So whatever micro operations are going to be performed in the system, for that control unit is responsible. When control unit sends the control signals, nothing but called as control word, then only all components are working. So register to register data transfer can be performed, true. Only when control unit will send the signal to registers, then only register to register transfer happens. Condition can be evaluated from branch, yes. When control unit send the signals to status register and all, then only condition check happens. Memory write can be performed. For that, memory should get the address plus data plus control signal write, so that memory can perform the write. Control unit only will send these signals. ALU perform operation, yes. ALU get the function code from control unit only, part of control word, so that ALU can perform the operation. So all options are correct. A, B, C, D. All options are correct. Everything. चलिए next one. Question number 15. Last 6 questions. Yes. Control unit is mummy. So every work happening in the house, mummy is only giving the instructions about it. Next question, question number 15. Let's go. Very simple it is. Consider the system in which in fetch cycle means instruction fetch cycle, of course, complete instruction is fetched. Full complete instruction is fetched, including the opcode and mode and addresses, everything is fetched. So instruction fetch done in single time and complete instruction is fetched. Which of the following addressing modes do or does not require memory access for operand after the fetch cycle? In which of the mode CPU will not need memory access later on? Okay, register mode. In the register mode, from where do we get the operand? From register, which is inside the CPU only. Registers are inside the CPU now, you know that, right? So option A, yes, it will not require memory access, true. Register indirect mode. Register indirect mode says, Babu, what? It says from the address part you will get a register, but inside the register you will not get the operand, you will get effective address. You go to the memory through that effective address to get the operand. So operand is taken from the memory itself. Memory access needed, yes. Option B, gone, wrong. It is not correct. Option B is not correct. See, as soon as you see register something, you will have to think about it, what register indirect mode does. Without thinking, if you just put the answer, register indirect, register, we are not going into memory, then gone. Just because you are actually not going into your memory. In memory, register indirect mode, if you check it out, memory is accessed. Indirect mode, operand is in the memory. In fact, 2 times memory access is needed. That to anyway everybody understands. From address part you get a memory address, go to that, you will get effective address. Again you access the memory, then you will get the operand. 2 memory accesses needed. So option C anyway wrong. Option D, indexed mode. In indexed mode, what happens? What happens? To calculate the effective address, the address part of instruction you add into index register part. Yes. But you are not getting the operand, Babu. Bawa. You are not getting operand through this addition. You are getting effective address. Use this effective address, go to memory, and you get the operand. Sir G, operand access needed from memory. Option D is also gone. Only option A is correct here also. PC relative requires memory access? No, it does not require memory access, but it does not require operand also. The question is talking about operand. PC relative mode is not needed when operand is needed. It is needed for the branching. Operand का जरूरत नहीं होता है वहां. There is no any operand there. After instruction fetch, PC relative mode will not require the memory access. Yes, true. But there will not be any need of operand over there. Chalo, next question. Question number 16. Okay, instruction chapter. I'll give you 2 minutes. Not even 2 minutes. 1 minute is enough, but still 1.5 minutes I'll give you to solve this question. You guys are very quick, yaar. Adopting the questions quickly. One and a half minute gone already. Wait, let's see. System which supports 30-bit instructions. System supports 45 one address instructions. Instruction size 30 bits. One address instruction will have opcode and one address. That's it. 45 instructions. For 45 instructions, what should be the size of opcode? What should be the size of opcode? 6 bit are enough. 6 bits are enough. So remaining 24 bits for address part. Maximum possible memory. If nothing is given in the question, I will take by default byte addressable memory. Should be mentioned in the question. That is my bad. If you are not considering this, consider this. You can change your answer. It should be mentioned in the question. It will always be there in the GATE exam for sure. So byte addressable, maximum possible memory is what? Use all the addresses. Maximum possible memory size is 2 power 24 addresses with 24 bits. On each address you store 1 byte. 2 power 4 is 16, 2 power 20 is mega. 16 megabyte is the maximum possible memory. Any memory which is lesser than this, my system can support, just because address size will be lesser required than 24 bits. So I won't mind it. I won't mind it. So option A, B and C are correct, where memory size is lesser than 16 MB or equal to 16 MB. So option A, B and C are correct. Can you watch this lecture after it ends? Yes, of course you can. For sure you can. Next question. Floating point representation question. Very easy. Very, very easy. Directly from why less than 16 MB? Akash, when you use address 24 bits, it doesn't mean that आपका address or your address should be always exactly 24 bits. The address length can be 24 bits or lesser for memory access. You can deploy the memory which can be lesser. You can deploy the memory which can be lesser than 24 bit, which has requirement of address lesser than 24 also. All the questions are easy medium. Toughest questions were at the first place plus in the test series. These are the questions where you need practice more and more. The tough question will not test you. The tough question will just give you the scare here. We are here to improve the practicability. Just access the test series. You will have a lot of good questions over there from COA and OS and other courses for sure. So question is about single precision IEEE format. What is the statement? Bias used in exponent is 127. Yes, true. 127 is biased is single precision. Next, denormalized numbers help represent values closer to 0 than the smallest normalized number. Yes. Smaller than should be smaller than. So those values which are lesser than the smallest possible normalized value, which cannot be stored as normalized value, we store them as denormalized value. That is also true. That is what the definition of denormalized value. We store the denormalized number like that way only. So that is working now. Still buffering. अभी चल रहा है. Okay. Let me explain it again. Where I left. Where I left, I don't know. So denormalized number, that is the definition. Those numbers are numbers which are lesser than those numbers which are normalized numbers, and we cannot normalize them. If we cannot normalize them, then we store them as denormalized number, which is close to 0, but not very, not 0, close to 0 and lesser than the normalized number. The mantissa we store as implicit normalized number. In implicit normalized number, we store like this way. Mantissa we store, that one is implicit leading one we have. Option C is correct. Option D, infinity is represented by all ones in exponent and all ones in mantissa. Wrong. We store infinity as exponent all 1 but mantissa all 0. If exponent is all 1 and mantissa not equals to 0, where it is, this option is actually talking about NaN, not a number, not the infinity. So option D is wrong. Option A, B, C are correct here. Next question. Very easy it is. सर ये ऐसी छोटी छोटी चीजें याद नहीं रहती हैं. Fatima Zariwala, math, there will be only single session. That will be on the decided date on Sunday, I guess. It will be on next to next Sunday, which is 18th, if I'm not wrong. And you will be having single session of math, only practice and practice. क्वेश्चन टाइम पर भूल जाते हैं, इसके लिए आपको प्रैक्टिस की जरूरत है. यू नीड टू प्रैक्टिस मोर एंड मोर एंड मोर एंड मोर एंड मोर. व्हेन यू विल प्रैक्टिस, you will be having correct answers. Maha revision tomorrow. You will be having I guess discrete mathematics, if I'm not wrong. I'll tell you in few minutes. No, digital logic. You will be having digital logic tomorrow with Gupta sir, Chandan Gupta sir, and then discrete math next. So next 2 days digital logic you will be having. Yes, Chandan sir. Okay, folks. What is the question? Consider IEEE 754 single precision floating point representation of numbers. Which of the following options do not or does not represent number which is greater than 0 and smaller than 1? Plus ka 1. So I will have to find out the number greater than 0, smaller than 1, not of this. Option B, I can directly commit just because it's a negative number. Negative number, any number does not fall between 0 to 1 for sure. Option A, when option A you see, it's a normalized number. It's a normalized number. If it is a normalized number, just because exponent is not all 0 and not all 1, normalized number, positive normalized number, okay, that positive normalized number value will be what? Let's see, what is the value? Value is plus 1 point Mentisa, so many ones, into 2 power, this is 1 of decimal, so 1 minus bias 127. This is how you get the value. Option A. 1 point Mentisa, all ones, multiply by 2 power this. 1.23 times 1, 2 power minus 126. If you take that minus 126 here, you'll be having this kind of number. So many zeros initially, just because I'll have to shift point 126 times left side. And then 1, 1, 1, 1, so many ones. Is this the number between 0 and 1? Yes. Between 0 and positive 1? Yes. So option A is in between 0 and 1. I'll have to find out not represent. So option A I cannot tick mark. Option C. Option C is denormalized number. Look at this. Denormalized number, not 0 of course, just because it's a denormalized number. As soon as you go with denormalized number, that also will fall between 0 and 1, positive number. Denormalized number is number very small, and that too between 0 and 1 for sure. So anyway, option C is gone. Option D, exponent is lesser than 1. Exponent is lesser than 1. No. Oh, exponent is too big here. Exponent is too big here. Okay, let me see. Option D. So how do you get the value? Exponent is 127. Is it 127? Yes, exponent is 127. Mentisa is all 0. Mentisa is all 0. Exponent is 127. So my value is positive just because sign is 0. 1 point Mentisa, which is all 0, multiply by 2 power exponent minus bias. Bias is also 127. It is 2 power 0, 2 power 0 is 1, positive 1. So option D represents positive 1. If option D represents positive 1, question says that smaller than 1, not exactly 1. So option D also we will choose. B and D are correct. B and D are correct. Very simple question it is. Again, very simple. 1 minute question. Where do you get Maha Revision Day Wise Planner? Yesterday. Yesterday only we have launched dinner. In that you can get it. I guess day before yesterday. After the class, I'll explain. After the class, I'll give you a table. I'll write down. 2 more questions are remaining. I'll write it down. Smaller than, sir, why choose? Yogesh Chaudhary, it is not less than 1, beta. Which of the following operations will need the program counter register? Return from interrupt service will need program counter, of course. As soon as you return from interrupt service, you need the program counter so that you can load the old program's value into program counter and you can resume the previous program. Function call, of course, just because function call is a jump. When you call the function, you jump to some other location. See, from this function, if you are calling another function, the other function is stored somewhere else in the memory. So jump is needed. If jump is needed, yes, unconditional jump, program counter needed for sure. Instruction fetch, program counter needed. All options are correct. All options are correct. Function call uses activation record. Yes. Anyway, program counter is needed there. In function call is nothing but it's a jump, unconditional jump. You need to jump on new location so that the next function which you want to execute can run, can execute. Next question. Why D? Instruction fetch. यार ऐसा क्वेश्चन पूछ के मुझे किडनी में हार्ट अटैक आ जाएगा. In instruction fetch, you need program counter, re baba. Then only you can get the next instructions address. Next, last question for the day. MSQ में बहुत मिस्टेक इसलिए होता है just because you cannot have correct concepts in your mind. Application of concepts and correct concepts, if you will have, you can solve the questions correctly. You need to practice and practice and practice and practice more. Question is simple, yet you need to understand all the type of architecture for that. Okay, let me explain you. Register architecture says that both the inputs are taken in ALU from register itself, general purpose register. Register and memory based architecture says that in ALU, one input taken from register and other input can be taken either from register or memory as per the requirement. Yep. And memory based architecture says that it's a complex system architecture where you can take both the inputs as per your choice, either register or memory. Second input also you can take either from register or memory, your choice. In register memory architecture, memory data cannot should be the statement, cannot be accessed without a separate load instruction first. No, possible. See, load instruction is needed in the register architecture always. Why? In register architecture, you need both the inputs taken from register only for ALU. So if you want to perform any addition, subtraction or any other ALU operation, you need first a particular load instruction, so that the operand can come from memory to register and then you can perform the operation on it. But in register memory based architecture, one input can be taken from register, other input can be taken from memory. So can not be, no, it can be. Register memory based architecture can take the operand from memory, one operand from memory without load instruction. Option A is gone, false. Cannot be accessed, false. So option A is false. Question says false only, so option A you will tick mark, it is a false statement. Option B, in register architecture, ALU instruction can take operands directly from memory. No, false. In register architecture, both the operands should be taken from general purpose register. Directly you cannot take operand from memory. First you need to bring the operand from memory to registers. C option, memory architecture does not waste memory registers or many registers for temporaries. True. In memory based architecture, both the operands you can directly take from memory. So you don't waste the registers to bring the operand from memory to register and keep them for temporary basis. No. Option C, that's why it is true. It does not waste a lot of registers just to keep the operands which are coming from memory. So option C is correct statement, true statement. The register architecture has higher instruction count than architectures with memory references in instruction for a user program. Yes, this is also true. Why? See, it's a very simple thing. If you want to perform operation A plus B, in memory based architecture, you can directly take operand from memory A and B and you can perform the operation. But in register based architecture, you need to first bring A into some register, then B into some register, then only you can perform operation A plus B, R1 plus R2. It will take more number of instructions to do the same task in register based architecture. That's why this says correct. Option A and B only are correct for this particular question. A and B are correct here. Okay, many different type of questions we have solved, which are potentially the concepts which should be recalled through these concepts. I hope you guys are getting a lot of concepts. See, still I'm telling you, you need a lot of practice. these sessions are only helpful for you guys so that you can have touch of those important concepts which you need to brush up at the end. But that is not only the thing you need to brush up. You need to keep practicing. I am keeping the sessions in such a way that entire day is not engaged. If your entire day is engaged, then you will certainly not have your own improvement and other things like writing the mocks and many other things. So we will have the sessions in such a way your some part of the day will be engaged here, remaining part you can still work on. So we will again meet at 7 p.m. Right now 4 p.m. it is almost 4 p.m. We have 3 hours for you guys. Take a small break till 4 p.m. and then you can continue till let's say next 2.5 hour or maybe 3 hours for your own preparation. Okay, before I conclude this particular session, I will give you the dates. So you have COA, revision and practice 3 and 4 January. Then these are almost done. 7 p.m. Mahabhyas session on GATE Wallah EEECCS channel. We are still having pending almost 20 or something questions we are having of different kind. We are going to solve NAT, MCQ, MSQ and all variety of questions. Then you have digital logic 5 and 6 January. Then after that you have discrete math 7 and 8 January. Then you have C programming, if I'm not wrong. Yes, 9 and 10. C programming 9 and 10 January. Then on 11th you will have CD compiler design. You will have only single day just because course is smaller. Single session, practice, revision, everything will be there. Okay. Apart from that, then you will have algorithm on Monday, Tuesday, again 12 and 13 January. Then you have DBMS. I will again meet you guys on 14th of January. 14 and 15 January, you will be having DBMS. Then you will have computer network 16 and 17. CN 16 and 17 January. Then 18th of January you will have math. Single session again, full day, revision practice. Anyway you need practice only. Then you have data structure 1920. Then TOC 21 and 22 January. Then you have operating system 23-24 January. Then aptitude. Again single day, single session 24 January, 25 January and done. This is the schedule. Okay, scoring 30 to 25 in mock test, you need to practice more and more and more. Only solution is practice and practice and practice. More practice, you will recall more concepts. If you remember the concepts very well, then practice is the only thing you need. More practice will help you increasing your marks. PYQ session will not be there this time just because a lot of students are already having PYQs already solved. So you can still watch last year's PYQ session. We are going to solve additional questions just because PYQ anyway available online. So you can have additional questions. It's a benefit for you guys. PYQ already there plus additional questions we are bringing. You will have good thing. Which teacher will teach which subject? Digital logic, Chandan Gupta sir. Discrete math, Satish Yadav sir. C programming and data structure, Abhishek Sharma sir. Algorithm, Aditya sir. DBMS revision I will take and practice. Satish Yadav sir will take computer network. Abhishek Sahu sir. Mathematics, Puneet sir. TOC, TOC I guess it will be taken between Venkat sir and RBR sir. I guess practice will take, RBR sir will take, and revision will be taken by the Venkat sir. Operating system I will take, aptitude Ratan sir, Amulya Ratan sir. Okay, after the session, in the Telegram group, Vishvadeep sir, PW, that's the Telegram group. There I'll drop the PDF as soon as possible. Okay, thank you so much. Have a great day. Bye bye.